Thank you. Next up, we've got Vlada coming to talk about overheating, designing to prevent overheating. So we're very grateful to have Vlada here to present today. Vlada is an architect with many years of experience with passive house at all sorts of different scales in Europe, and has now been in New Zealand for
8 or 9 years.
8 or 9 years, and doing a lot of passive house projects here in New Zealand also. I'll hand over to you then.
Thank you. Thank you very much for attending conference and being passionate about passive house and energy efficient and sustainable design. I'm an architect from Europe, engineer of architecture, certified passive house designer, Green Star accredited professional, engineer of energy efficiency, trained for Nutkers and neighbors, and I started my journey with lead associate trainings, and after decades I realized that I'm more person for passive house, and so my presentation today, or segments of today's presentation, will be related to practical aspects of architectural and passive house design, and there will be some information I'm going to share with you. Probably something will sound strange to you, but I'm happy to share some of those things with you. So I've just landed literally from Europe, where I spent 3 months or maybe longer there, and so there are a couple of things there related to my journey. Firstly, I'm still facing jet lag. That's the one. The other one is that I was there where we had the highest recorded temperatures there. So let's say something about impact on the human population and the quality of our living. So we are growing our concerns about the consequences due to climate change and the global warming, and it is affecting human population and the quality of our lives. So it affects the food we eat, the air we breathe, the water we drink, and so it affects the places in which we live. So that there is a big impact on people's health and well-being. There are some questions: how do people respond to heat? And also, so there are some questions related how people react when we are exposed to the high temperatures for longer period. And one of the consequences is just number of heat illness, or it could be heat-related deaths, which is a growing concern in Europe currently. So there is also discussion about the impact of buildings on the environment and the importance of the quality of the internal environment there. So some information about the latest summer there. But before I said it, so there are some questions regarding physiology of the heat stress, and there is a methodology for assessing overheating, so prescribed or so just proposed by CIPSE. And so there is a technical memorandum 52 with 3 criteria, monitoring maximum temperatures and temperatures during summer. Anyway, so going back to that graph we see here, so we can see the crazy high temperatures in Europe this summer. So we recorded the hottest summer ever there. So, and what we can see that 2023 we had 47,000 people died in Europe as a result of high temperatures. For example, I spent most of my time in southern of Europe, so where in Greece, Bulgaria, Croatia, Serbia, and so we see that. So last year we had 393 deaths per million in Greece, which is extremely high rate. So summer 2024 was the warmest across Europe with 1.45 Celsius degrees above the average when comparing to a period of 1991 and 2020. And this year's Southern Europe region achieved 4.2 or 4.4 degrees Celsius above the average temperature. So which raises too many questions, especially in terms of the Paris Protocol, Overheating in dwellings is a major issue for public health concerns in Europe. So global warming is increasing overheating risk in dwellings, and consequently we have increasing cooling energy demands. Also, so we can find a close relationship between high indoor temperatures and people's well-being and health and mortality rates. There was a crazy story from 2003 when 50,000 people died across Europe due to heat in period between August 1st and August 20. So, and that year only in Paris, 50,000 people died. So we have to be aware of the current situation and that nature is going to something that no one expected. There is a part which we can contribute or just to demonstrate what our knowledge and our skills, and it's related to the architectural and passive house design. So we can see that a lot of people were suffering health issues, including the workplace productivity due to overheating in buildings. So, and we may say that overheating happens in a building due to bad design, poor management, and or inadequate service. So also there are a couple of things just that we have to take into account, especially so when we are quantifying the combined impact of building features on overheating. One of the important things for architects and designers is to understand the impact of increased insulation on overheating risk. There was a recent public discussion that the insulation or super insulation could be a reason for overheating. But according to the latest research, it is only up to 5% of overall overheating response that we can account to the insulation. So which means that the rest of 95% is related to other questions, and especially that the highest portion of overheating issues is directly associated with poor design. So we should be very careful as a profession. So when start doing architectural design, we have to just identify overheating risks. So, but global warming is increasing overheating risks in dwellings, and consequently cooling energy demand is increasing. So exposure to the extended periods of high temperatures can cause a range of direct and indirect health issues, and so reduced productivity. So there are different terminologies, and so in terms of, and so there are so different ways of assessment. So in Europe, most of the researchers they consider as a SIPSE and TM59 assessment as the most productive way of assessing overheating risks. So there are two criterions as per TM59. Criterion A is a hours of exceedance, which applies to kitchens, living areas, and bedrooms. For living rooms, kitchens, and bedrooms, number of hours during which the temperature is greater than or equal to 1 Celsius degrees greater than the comfort temperature should not be more than 3% of occupied hours. And criterion B is related to the night hours above 26, which only applies to bedrooms. So one of my, I'm focused on passive house design project management and architectural design project management. And so when it comes to casual discussion about architectural design, so everyone is able to speak and to understand, all of those aspects of architectural design. So, and there are key stages. So planning, execution, monitoring, and control, of course. So there are two stages more, which is initiation and closure of the project. So this is a standard project management approach. But project management in passive house and architectural design just is the same like others. What we have to just pay attention is risk management as a critical component of architectural design project management. So we have to identify potential risks that could impact the project. So, and in terms of today's discussion, so there are some important things that will be related to our knowledge on overheating risks and how to prevent some of those things later. So when we speak about risk management, so we have to be focused on identifying and analyzing all important factors in the passive house design and construction process as well. So there is a stage of execution where we have to insist on procedures. What I found from my experience that people are not so keen to follow procedures. And the whole story about PHPP is related to following the procedures. So sometimes people forget just to go one by one or to create a checklist when doing design. So also what's highly important for the execution, that we delegate work to a team member who has proven record in passive house design. So it's not only enough to say I'm certified passive house designer or Green-Star accredited professional if we don't have practical knowledge, and so if we don't have certified houses. So it's not only just important for our clients, it's important for our builders, because they need us just to be able to respond to every question and to respond to possible issues in the construction phase. There are possible risks associated with design. So this is a standard. It's a procurement process. It's a design stage, construction and commissioning. But speaking of the role of architects and designers, so the highest risk is associated with design because everything we create will come to someone stable. And so especially builders could have a nightmares due to poor design. There are design strategies, measures, and tools that we can use in our combat against overheating. Overheating as an issue should be considered from the start of design process. And speaking of just New Zealand climate, just we can say that we have two things to consider when start designing. So we have overheating mechanism coming from solar gains and or internal gains. So the number one is to control solar gains and try to avoid overheating. So there are some standard parameters. But when we start from building orientation, ideal is north-south. From my experience, we can go plus minus from north, but ideally it should be north-south orientation. It's not always possible due to some brief points, but anyway, so let's try always to be focused on the orientation and the proportion of the glazing. So it should be 15 to 25% of the TFA. Some of the authors, they say that it shouldn't be above 20% of the TFA. And also we have to pay attention on the windows orientation and percentage. So going to achieve less than 35% of windows on the northern glazing, 15% on the south windows, 15% on east and western to be less than 12 or ideally less than 10. We have to pay attention on internal heat sources, and especially so for domestic hot water system with low heat losses, having short pipe work, so and having good insulation on the pipe work. Also, we have to be focused on energy efficient equipment and appliances. There are some additional measures when doing design. So increased summer ventilation, heat recovery bypass, to consider surface colors. Also, it's part of the aesthetics. Then night ventilation, taking into account landscaping, so with plants and trees, and if possible, to use pre-cooling the fresh air intake. Sorry for that, G indicators, it should be key indicators. So, so there's a design strategy, measures and tools we have to take into consideration in early stage of our design. So just, although in passive house standards, so threshold is less than 10% of overheating, but from my experience here in New Zealand, and so I would recommend to be below 3%. All of my projects I designed, and so that the houses were certified is below 2%. Also, just to try to achieve daily temperature stock below 3 kelvins. So to try to achieve domestic hot water losses below 6 kilowatt hours per square meter. Also, just to achieve that windows to treated floor area proportion to be 50 to 25, or ideally to be below 20. So ventilation air change rate to be below 0.5 air changes per hour. And also just to have ventilation air change rate from windows, and also to have a nighttime changes to be below 0.1. So these are some recommendations from authors across Europe. And so as a prevention of overheating and some measures and tools for overheating issues. So I just want to say something about one of certified houses we designed. So it will be part of the segment that I would comment some things there. So it's from practical area of our profession. So this is a certified house in New Plymouth, and in early stage of discussion with the clients. So we had some initial brief, and let's say the client requested from us to have house parallel to the boundary there, and it was a 4-bedroom house with 217 treated floor area square meters, and clients wanted to have floor to ceiling height windows, high windows, so with massive openings. And after having just a brief with the team there, so we propose north orientation as a more efficient. And so we recommended our client that we're gonna go for 2.1 meter high windows, and to reduce the glazing percentage. And also what we were trying just to explain, that we're gonna propose some of the external shading features. And client accepted most of our ideas, which was good. And there are just a couple of screenshots from energy modeling. And there are just 2 verification pages showing results. So the house was certified, and what we had there, just initial idea and final concept comparison. So originally orientation was considered to be minus 39 degrees from north, with full windows and doors height, with no pergola. And that initial idea was with windows to treated floor area percentage of 25, which was still not too bad. And what we got after having preliminary energy modeling, we got overheating rate of 14.4. Anyway, so just something that we proposed to our client was just to have a true orientation to the north. So windows door height 2.1. We added pergola, and so we achieved windows to treated floor area 20.5%. So the final certified overheating rate was 0.25. So we can see that the difference in overheating rate is a massive. Although that overheating rate for the initial concept is not so dramatic, and it could be solved with active cooling. Anyway, so my approach is more conservative, And I'm always voting for passive cooling. So there is always chance to do something with active cooling. Having active cooling involved as an idea. So we know that we're going to spend more energy for cooling. Having seen current trends, in global changes, so most of the houses probably will suffer soon issues with overheating. Anyway, so that's the house, and something that I wanted to talk about fossilized professional habits. So most of the architects, so they want to have massive glazing areas, and so also having concerns that small windows won't look nice. So that house, oh yeah, okay, that was the house that was awarded in 7 categories, and it doesn't look too bad. So I'm gonna finish this presentation, but what I want to say, so I was involved in some projects as a consultant, so where we had 42% of overheating, and the other one was 46% of overheating. So this was crazy, So both buildings were nicely designed, So one was designed by certified passive house designer. So it was a question, so what was the problem? So with achieving the 47% overheating. So that's something that we have to work on our education. And so we are responsible to be efficient in our design, and we have to build for the future. So we have Paris Agreement, which is legally binding, internationally treaty on climate change. So limiting warming 1.5, but so we already have in Europe 1.54, and so we have 4.4 degrees above the average temperatures. So what we have to do is to construct zero carbon buildings, optimize building energy consumption, decarbonize building energy use, and to work on ourselves and our education, and to be brave to change some habits, and to design for the future. I would like to thank Maria Laura for technical support for this presentation, and also for Milica Nešić, and sorry if it was longer than anticipated. Thank you very much for your attention.